Welcome, pre-algebra class, to another attempt at not falling asleep during fractions and decimals. This is lesson 13 on page 94 if you're following along in the book. So, do you remember fractions and decimals? Well, fractions, they're just another way of writing a division operation, right? So if you were to write, for example, 1 as in one cookie, and you wanted to divide that cookie into two pieces, then you would have 1/2 of a cookie, right? These two things are identical. If you were to convert this 1/2 fraction into a decimal, you would get 0.5, right? But this number doesn't end here. We just stop writing here. It keeps going with an infinite number of zeros, right? And so any decimal can also be called a repeating decimal because the decimal form repeats in every instance, right? But when we think of this number, we think of just 0.5, and we call it a terminating decimal. Terminating decimal. This is where the decimal form repeats with zeros. So that's the difference between a repeating decimal and a terminating decimal. Terminating decimal is a type of repeating decimal. Okay. For example, let's write 7/8 as a decimal. Well, 7 divided by 8. We can do this with long division. We can also just do this with a calculator, which is what I'm going to do. 7 divided by 8, I believe it is 0.875. So this goes on with zeros forever, right? But we don't write this. We only write this, as you've done ever since you started dividing. Okay. Oops. So I would like for you to write this as a decimal. Welcome back. I hope you did it. 4 divided by 5 can be written also, oops, that's funny. Like this. So how many times does 5 go into 40? 8. So this is 0.8. 0.8. Okie dokie. Here we have another example. Go ahead and try this one as well. Welcome back. Here we go. Let's do it together. 3 divided by 16. I'm just going to do this with a calculator. This is 0.1875. Another terminating decimal. Okay. Some decimals are not terminating. Some of them just repeat with other digits that are not 0. In that case, we use something called bar notation. Bar notation is using a line to indicate what numbers repeat. So for example, 0.3 repeating looks like that. This is the same as 1/3. Here's an example. So if we were to do this division problem, 5 divided by 6, 50. This goes into it. How many times? 8? 8 times? 8 is 48. 2. 3. Oh, looks like it repeats there. 0.833. That is the terminating decimal. I'm sorry, that is the repeating decimal for this fraction. And this is a negative, so the answer is going to be negative. So there you have it. Okay. Go ahead and try this one on your own. And we're back. 7 divided by 9. 70, that's 8. 63. Right? No. 8 is 72. 63 is 7. As you can see, I've memorized my multiplication facts. All right. 7, so now we already have a repeating decimal. So 7 over 9 equals 0.7 repeating. Okay. Here are some fraction decimal equivalents. These are ones that you might just memorize over time. You might already have some of these memorized. I'm not asking you to memorize these. This is just like the multiplication table. It makes things faster, but is not required. It just makes your calculation speed faster when you need to calculate things. All right, so let's look at some real world examples. According to the USDA, I'm just going to take a second to talk about this. The USDA is the United States Department of Agriculture. And they're in charge of farming, forests, and livestock. And so this is the department of the government that is in charge of making money for the United States on the production of food and the production of wood. And so would you want a entity that's in charge of making food to be making recommendations on what you should eat? I don't think so. Because, so for example, would you want the alcohol companies giving you a recommendation for how much alcohol you should drink every day? No, you should not, because they have an interest in getting you to drink alcohol, right? And in the same way, the Department of Agriculture has an interest in you consuming the products that they make money off of. And so they recommend that the average teenage boy consumes 2,700 calories per day. And they're saying that 360 calories should come from milk, which is a direct profit center for them. This is one of the things they make money off of. And they think that you should be eating it or drinking it every single day, which is crazy for a number of reasons. And there are a lot of scientific research that says that consuming dairy products such as milk and cheese is actually not good for humans. But anyway, enough of that. Let's just talk about this problem. 2,700 calories, 360 calories from milk. To the nearest hundredth, what part of a teenage boy's total calorie intake should come from milk? So earlier we talked about dividing a cookie into pieces, right? And we started with the whole cookie and we cut that cookie into parts, right? Well, that's how you should think about division. Division is basically a total amount and then a part of that total amount, right? So what part of teenage boys' total calories should come from milk? Well, the total calories is 2,700 calories, and 360 should come from milk. So 360 is the part, and 2700 is the total. So, just like this example with a cookie, if you had this piece of the cookie, then you have one part of a total of two parts, right? Half a cookie looks like this. So 360 calories, that's a part, over 2,700 calories, that's a total. And that's it. But we shouldn't leave it like this. We should simplify it. So first we can divide both by 10. And we can continue to simplify this. We can divide both by 2, right? 270 divided by 2 is 150, 135. And can we continue to simplify this? We might be able to. Yeah, we can divide both by 3, right? So that'd be 6, 135. 135 divided by 3 is 4, 12, 15, 5. 6 over 45. But we can still divide this by 3, right? So 2 over 15. 2 over 15. This is our final simplified answer. That is the what part of a teenager's calories should come from milk. 2 parts out of every 15 parts, which is crazy. Don't do that. Do not follow this corrupt government's recommendations. So, here's one for you to do yourself. In a recent Masters tournament, Zach Johnson's first shot landed on a fairway 45 out of 65 times. This is golf. This is the sport of golf. When you hit the ball and it lands on the nice piece of grass, this is called the fairway. It lands on the fairway 45 out of 56 times to the nearest thousandth. So now we're going to be converting to decimals. What part of the time did his shot land on the fairway? Go ahead and do that on your own. Welcome back. Okay, so 45 is the part, right? Out of 56, that is the total number of times that he shot. So, I guess the easiest way to do this would just to be with division. And so, that comes out to be 0.8035714, so on and so forth. Okay. But we're only interested in the nearest thousandth. So, as a reminder, if this is the zeros place, then this is the tenths, hundredths, and then thousandths. So that's 3 decimal places past. The 4th decimal place is 5 or above, so you round up. So this is going to be 0.804. If anyone cannot remember how to round to the nearest hundredth, tenth, any of the decimals, then let me know and we will go over that. Okay. Fractions are awesome. I personally like to work in fractions because fractions are in many cases more precise. And the example I'll use is 0.3 repeating is equal to 1/3. If you were going to do math on this, you lose a lot of your preciseness and accuracy when you lop off these numbers, when you do rounding, like we just did in the previous number, right? We rounded that number to 0.84, even though 45 out of 56 is the actual number. This represents, with complete accuracy, that quantity. But decimals are still good for other things. And sometimes you will have to use decimals, or you'll be given decimals, and you have to compare them to fractions. So which one is bigger here? This is greater than, less than, equal to kind of a problem. So 7 divided by 9, I would convert this to a decimal, and you would get 0.7 repeating, which is going to be less than 0.87. Here we have another one that are both fractions. You could do whatever you wanted, but I would convert to decimal because I think comparing with decimals is always easier unless the denominator is the same. And if you're going to go through the work of creating the same denominator, then I think you might as well just do the work of finding the decimal. So 7 divided by 15 is 0.46 repeating, and this is a negative number. 5 divided by 12 is 0.416 repeating. And so these are both negative numbers. Which one is bigger? Well, this has a smaller absolute value, which means that this is the bigger number. Because remember, on a number line, as we get further and further away from 0, the smaller it becomes, right? And so we want the number with a smaller absolute value when we're talking about negative numbers. Okay, this video is getting long. Let's try to wrap this up. 30 out of 36 7th graders and 34 out of 40 8th graders participated in a marathon. A marathon is a really, really long run, 26 point something miles or something like that, for charity. Good for them. Which class had a greater fraction participating in the marathon? So 30 over 36 and 34 over 40. Which number is bigger? Again, I would probably just convert to fractions or decimals because calculators are awesome at this kind of thing. So 30 divided by 36 is 0.83 repeating. 34 divided by 40 is 0.85. Oh, the 8th graders. The 8th graders have a greater fraction of participants. Come on, 7th graders. Pick up the slack. For example, over the weekend, 16 out of 28 of the 8th graders and 19 out of 30 of the 8th grade girls and 19 out of 30 of the 8th grade boys went to see BTS perform at Henshin Arena. Did a greater fraction of the girls or boys see the boy band? Figure it out. We'll be right back. Welcome back. Okay, so 16 out of 28 of the girls and 19 out of 30 of the boys. The boys. So here we have 0.571, and here we have 0.63 repeating. So look at that. The boys love the BTS. Good for them. Okay. I hope you enjoyed this video. See you later.